Okay, hello everyone. So welcome to another video on this channel, and in this video we're going to be talking about the inverse function. So before we actually move forward, I'd like to advise those who have not watched the previous videos. I'll advise you to kindly check it out because you will need knowledge from that video to understand this video if you are new to functions. So basically, at the end of this video, you should understand how to find the inverse of a function and why we take the steps we take in finding the inverse function. So without further ado, let's move forward. Okay, so before we move into solving problems on the inverse of a function, let's understand what we are doing. Now, the inverse of a function is a function that serves to undo that function. So let's say you're a factory worker and in your workplace you work with machines. So your boss tells you that you should convert out of 100 inputs to convert 50 of them to output using the machine. So now maybe you did a mistake in the conversion process and then you converted more than 50. Let's say you converted 60 instead of 50. Now how do you turn the 10 back to the inputs? That is, how do you turn the 10 outputs which are not meant to be turned into outputs back to inputs? So now let's look at it in this case. So this is the input X here. It goes into the machine and then produces the output Y. So now you made a mistake and then you want to convert those 10 inputs, sorry, 10 outputs rather, back to inputs. So now you put back those outputs inside another machine which does the job to convert it back to inputs. So now F is a machine and then F inverse does the opposite of what F does. So F takes X values and maps it to Y. F inverse takes the output values and maps it back to the input values. So that is basically what the inverse is. So now let's say we have two input values giving the same output value. So let's say we put 2 and minus 2 into a function and it gives us the same output value. When we take it to F inverse and we put that output value, the machine will be confused on which value to produce. Since 2 and minus 2 gave it, the machine can't produce 2 of them. Remember, a function must produce only one output. So I'm saying that F inverse is also a function on its own. So it must produce only one output. So note that if two input values produce the same output value in a function, that function does not have an inverse. So always note that. So now suppose that F is such that elements of A are mapped to the range which is inside B, and then we know that F inverse does the opposite. It takes this guy B back to A. So X values are in A and Y values are in B. So in this case, Y values are in B and X values are in A. So for here, if you say that the output value is Y is equal to F of X, it implies that here the input value will be, the output value will be X is equal to F inverse of Y. Because when you put your input value here, Y, you will get the output F inverse of Y. So X is going to be equal to that. Same thing with F here. Once you put your output value, put your input value rather X into the function, you're going to have F of X, which is going to be the output. So Y is going to be F of X. Remember that Y is the output in F, and then in F inverse, X is the output. So let's see the steps in which we can find the inverse of a function. Okay, so how to find the inverse of a function. So the first step says we should set Y to be F of X. So that means Y is going to be the output value. Is that what this first step means? And the second step says we should make S the subject of formula. The third rule says we should replace X with F inverse of Y since S is equal to F inverse of Y. We saw that previously, that if Y is F of X, that means X, which is the output value of F inverse, is going to be F inverse of Y, with Y being the input value in F inverse. So the last rule says we should replace Y with X. So let's see if we can apply this to some examples. So I actually advise you to note this down as we continue to the example so that you can follow everything I'm doing. Okay, so the first example says we should find the inverse of f of x equal to 2x plus 3. So remember that step 1 says we should set y to be f of x. So let y be equal to f of x. Now if y is equal to f of x, this implies that y is equal to 2x plus 3. So the second step says we should make s the subject of formula. So we should make s the subject of formula. We're going to move this plus 3 to the other side. So this is going to be y minus 3 is equal to 2x. Dividing both sides by 2, this is going to be over 2 over 2, which implies that x is equal to y minus 3 over 2. So the third step says we should replace x with f inverse of y, since x is equal to f inverse of y. So basically, this x here turns to f inverse of y. So f inverse of y is equal to y minus 3 over 2. And lastly, the last step says we should replace y with x. So f inverse of x is equal to x minus 3 over 2. So you can see that it was actually very easy using these 4 steps. So let's look at another example. Okay, so the next example says we should find the inverse of f of x is equal to 2x plus 3 divided by x plus 1. So remember that the first step says we should let y be f of x. So let y be equal to 2x plus 3 over x plus 1. Now remember that 2x plus 3 over x plus 1 is f of x. So y being equal to f of x implies that y is equal to 2x plus 3 divided by x plus 1. So the next step says we should make x the subject of formula. So this is over 1 and we're going to cross multiply. So this is going to be 2x plus 3 times this one is equal to y times x plus 1. 2x plus 3 is equal to y times x, xy, y times 1, y. So now we're going to move every term that have an x with it to the other side, to one side, and then move the ones that don't have to the other side. So this implies that 2x minus xy is equal to y minus 3. So we're going to factorize x from this side of the equation. So this implies that x into 2 minus y is equal to y minus 3. Dividing both sides by 2 minus y, we're going to have that x is equal to y minus 3 divided by 2 minus y. So now, the third step says that we should replace x with f inverse of y. So this x here over here is going to turn to f inverse of y. So f inverse of y is equal to y minus 3 over 2 minus y. And lastly, the last step says we should replace y with x. So replacing this y over here with x, this y here and this y here with x, it implies that f inverse of x is equal to x minus 3 over 2 minus x. So this is the inverse of f of x here. So let's look at another problem. Okay, so the next example says we should find the inverse of f of x equal to e to the power of 3x minus 1. So the first step says we should let y be equal to f of x. Now this implies that y is going to be equal to e raised to power 3x minus 1. Now we're going to make s the subject of formula, which is the second step. So we're going to remove terms that don't involve x to the other side, and then terms that have x to one side. So this is going to be y plus 1 is equal to e raised to power 3x. Now recall that the natural logarithm of e raised to power x is x. So we're going to apply the natural logarithm to both sides of the equation. So this implies that the natural logarithm of y plus 1 is equal to the natural logarithm of e raised to power 3x. Now, since the natural logarithm of e raised power x is x, this guy over here is going to be 3x. So basically we have that the natural logarithm of y plus 1 is equal to 3x. So we just divide both sides by 3. And this implies that x is equal to the natural logarithm of y plus 1 divided by 3. So this was actually very easy. So now the next step says we should replace x with f inverse of y. So we're going to replace x with f inverse of y. So this implies that f inverse of y is equal to the natural logarithm of y plus 1 divided by 3. Now the last step says we should replace y with x. So this implies that f inverse of x is equal to the natural logarithm of x plus 1 over 3. So basically this is the answer of the question. So let's solve our last problem, and yeah, you can try more examples by yourself. Alright, so for the final problem, we are told to find the inverse of f of x equal to the natural logarithm of 2x minus 3 plus 2. So remember that we let y be equal to f of x. Now y being equal to f of x implies that y is equal to the natural logarithm of 2x minus 3 plus 2. So now we're going to make s the subject of formula. So y minus 2 will be equal to the natural logarithm of 2x minus 3. Now remember that e raised power ln x is equal to x from the rules of logarithm. Now we're going to raise e to the power of this guy over here, and then raise e to the power of this guy over here. So this implies that e to the power of y minus 2 is equal to e to the power of ln 2x minus 3. Now this guy over here is going to turn to 2x minus 3. Reason being that e raised power ln x is equal to x. So e raised power natural logarithm of 2x minus 3 is going to turn to 2x minus 3. So basically we have that e raised power y minus 2 is equal to 2x minus 3. This implies that e raised power y minus 2 plus 3 is equal to 2x. So dividing both sides by 2, it implies that x is equal to e raised power y minus 2 plus 3 divided by 2. So now the next step is to set x to be f inverse of y. So this implies that f inverse of y will be equal to e raised power y minus 2 plus 3 divided by 2. And lastly, we're going to set x, y, we're going to replace y with x. So this implies that we're going to replace y with x here, and I think that is all. So f inverse of x is equal to e to the power of x minus 2 plus 3 divided by 2. So this is your answer. So we've come to the end of this video, and if you found this video useful, you can help me by liking this video, sharing it to your friends, and subscribing. And also help me like my Facebook page. The link will be in the description below. Thank you so much, and enjoy the rest of your day.